let's work on our JiEnergy library. Hello everyone, this is Jiralib. Welcome to the Mentor Code Lab. In this episode, we will start working on JiEnergy, and as always, we need to start with the connector. I did add the packages based on what I think we need, but it may change. And instead of starting from the connector, actually, let's start with the storage space first. That makes sense. All we need is a synced energy storage. And as I said before, the energy system is much simpler compared to fluid. If you could handle the fluid, this is a paradise for you. So synced fluid storage will extend energy storage, but not the energy storage. It will extend simple energy storage. This comes from the tech reborn, as you see on top, and it will implement the iSyncable from the base from my library. So let's implement the methods, and that is get sync, and then let's have a constructing matching super. Now in the constructor, as you see, we are asking for a capacity, a max input and max extract. However, here we want to track things. So I will say private final. This is the block entity, but because it's synced, we want our own type, maybe. Yes. So G block entity, and we call it block entity. Then we will have is dirty. So private boolean is dirty. That by default is false. Here we will ask for the G block entity of any type, and we call it block entity. After calling the super, we cache our block entity, and that's it. Then we have something before sync, and because we are working with energy, that is on final commit, we are calling the super here, and after the super, or we are doing saying that is dirty equals to true. Then on the sync, we say if this is dirty and block entity does not equal to null, and block entity dot has word and not this dot block entity dot get word dot is client. Now it will give me a warning about the word. We should always ignore this. However, I will just suppress this one. If that's the case, we want to do two things. First, this dot is dirty equals to false. We reset it back, and then we say this dot block entity dot update. Now this is what 30worthy has, and finally get block entity that returns the block entity. If we want to, we can convert this to use any block entity, and here we should check if the block entity is updatable, then update. If not, then we just say mark dirty. The thing is that using G block entity, I will force people to use the Jiralib. Let me double check if I did the same thing on the fluid or not, because if it's block entity, then marking dirty doesn't cut the thing. No, actually I use the block entity, so let's go with that. I want to be consistent between my libraries, so block entity, and yes, I need that later. Here I will return block entity. However, this time I will check if the block entity is actually an instance of any block entity that is mine. I will call it BE, then I will say BE.update, else we say block entity.mark dirty. So here in the constructor, again, we want to accept a block entity and not our type. Next, we will have these interfaces, iFluid container. Now we will have iEnergy container. So iEnergy connector actually. And if we take a look at this one to copy things, it's this. However, instead, this time we go with simple energy storage. Instead, we are returning energy connector that we don't have yet. Anything else that we need before going anywhere else? Now, as I said, energy is much simpler than fluid. So we don't have predicate, we don't have input, output. Do we want that? Any machine can have inputs for energy. Some machines may want to export energy but not accept energy. Yeah, we can do that. Why not? So I will take this guy to the other monitor. I will add them, and these are some things that are mine, not anyone else's. So we will have predicate energy storage, and this guy will extend the synced energy storage. So of course we will have the constructor matching super, but this time After the extract, we will ask for a predicate of simple energy storage. It will be a Boolean, and we call it can insert, and a predicate of Boolean can extract. I will just hit Alt Enter, not that, goddammit. Alt Enter, create field, can insert. Alt Enter, can extract. Do we have can insert? Get can insert. Look at that name. So this is an override. No, it's not. What? Don't we have something like this? Let's take a look. Simple energy storage, insert and extract, get amount and capacity. And the snapshot participant, none of that. So we don't have that. Okay, can insert and not get, for goddammit sake. It will return a Boolean now. This dot can insert dot, why am I asking for a predicate? It can be a simple Boolean, you know. It really can be a simple Boolean, because when you want a predicate, you're assuming that something should happen in the predicate. For energy, we don't have that. We just can have a Boolean here instead of all of that, and it will simplify things. So Boolean and Boolean. For God's sake, what was I thinking? Well, I know what I was thinking. I was looking at the fluid predicate, but that's it. Finally, public bool can extract, and bool comes from C#. Return this that can extract. That is our predicate. Then we have the input and output. Yeah, input energy storage. This will extend predicate energy storage, do the construct matching super, and we are just accepting the can extract because can insert is always true. Do we want an overload for this? Why not? We don't accept can extract either. We call this super. For the can extract, we say always true. No, actually, what was I thinking? It's false. This is can extract. Okay, it should never be able to extract. So that's it. Then we will have the output energy storage. Again, it will extend predicate energy storage. Create constructor. This guy will not insert, so it's false, and the extract is true. Okay, that's that. Then we will have our other things. So we covered this storage, this container. We will come back to utils. On the client side, we don't want to render anything in the world. There's nothing for interacting with block. Yeah, we are ending with the connector and the block entity. For the connector, it is energy connector. The energy connector extends the storage connector of type energy storage. Finally, I can implement methods, write MBT, read MBT. After that, I want things from my own nodes. Take note, the storage connector has these add storages that is accepting no direction, map direction, and direction. We don't need to do them. Get storages is the same. We don't need to do them. So let me comment my nodes. We don't need any of this anymore. We don't need any of this anymore. And from top to bottom, we are ending with these. Okay, so we want to have a method for getting the amount. So public long get amount, and all we are providing is mapped direction. Hopefully this will be easier. So return get a storage on the direction and get amount. As I said, it's much simpler compared to what we had for fluids, because simple storages, whoa, they are really simple. We want a direction, and this one, we want to import a class because we are ambiguous here. We are using the one from Minecraft. Finally, we use the integer, so int index, that will work. Now that is our amount. We want capacity. Just copy all of that, paste it, change it to get capacity, and all we are doing here, we are getting the capacity. So get capacity, let me copy paste so that we move forward faster. After the capacity, we have the amount, we have the capacity, then we have max insert and max extract. So this is get max insert, and we say get, what did change there? Why can't I have the max insert and max extract? Supports extraction, supports, oh, that's the thing, supports, okay, I need to rewrite my predicates. Okay, apparently the simple storage is not providing the max extract and max insert anymore. No, actually the energy storage is not doing that. If we had simple energy storage, that was totally different story. Let me try. If we go with simple energy storage dot max, yeah, here we go, max insert. Now, do I want simple energy storage or energy storage? Do we have anything other than simple energy storage? So energy storage, we just have energy storage and simple energy storage. No, I want to be simple energy storage. That's much better. So This is max insert. And now the predicate, did we have that support? Yeah, supports insertion and supports extraction. That is what I was looking for. So supports extraction, that, and we don't need to touch the input output because that's the same thing. Okay, going back, we have our max insert and we need max extract. So again, max extract, and here we get max extract. So this is the biggest change between me and what Turtiworthy had. I will go with the simple energy storage and not the energy storage, because the simple energy storage still should be able to handle the insertion and extraction. Yes, insert and extract. But compared to the energy storage, because it's implementing energy storage is just support, insert, extract, get amount, get capacity. And it's used to be saving the side. So in my opinion, simple energy storage is a better implementation. By doing this, believe it or not, we are almost done with our helper methods. The only thing remaining is reading and writing NBT. Now let's start with writing NBT. We say var NBT list. We call it list. Then we say for energy storage, we call it storage. Inside the storages, NBT compound, we call it NBT, equals to new NBT compound. Then we say NBT.put, go with long first, the amount. Do we want to have the capacity? Simple energy storage, I'm not sure it can change the capacity or not. It should be, because we are retrieving the capacity there, so it should be able to change the capacity. Do I want to put that capacity inside the NBT? Why not? Let's do that. NBT.put long capacity. Finally, we say list.add NBT, and at the end, we return the list. When we are reading that, we say for I, so that I can have easier way of handling this. The index will be nbt.size at maximum. We increment. Then we say nbt compound equals to nbt.get or empty for the index. Then we say energy storage, we call it a storage, equals to this dot storages dot get at index. Then we go with long amount equals to compound get long for the amount, and if we don't find that, we go with 0 long capacity for the capacity. Thank you. If storage is instance of simple energy storage, that's the case, that should be the case all the time, then we want to say simple energy, we call it simple energy storage. Let's say simple energy storage dot amount equals to the amount that we got. Come on, be smart for the capacity. You're not handling it. Okay, symbol dot capacity equals to the capacity. And this is why we are not gonna store it, because I think this is final. No changing the capacity. Now, if I want to convert this to energy storage and follow what Turtiworthy has, if we are not simple energy storage, he's using transactions. I talked about this situation in the fluid container, and I said that I don't like to have transactions on read and write NBT, because normally read and write will not happen so often, but in case of cables, they will. There is no other implementation for the energy storage. If we find the usages of energy storage, 153. Okay, use on import, extends, implements. That's what I want, and not there. I want it on the energy. Let's take a look. Delegating energy storage, infinite energy storage, limiting energy. Whoa. Simple energy storage, simple-sided energy container, simple item energy storage implementation, empty energy storage. Okay, so question, should I roll back to being energy storage? If I roll back to be energy storage, then we will have a more robust solution up to writing and reading MBT. Now for these, we will have problem, because for example, delegate energy storage, this does not have anything. It has get amount, get capacity. This guy should have the same thing, yes. So energy storage actually should have the amount and capacity. Why don't you have that? Because it's override. Yeah, it has get amount and get capacity. So why can't I get access to it? If I roll back to the energy storage, okay, no, max insert, max extract, these two. I'm really not sure. Well, let's take a look. What are these things? For example, delegate. It says an energy storage that delegates to another energy storage in an optional Boolean supplier to check that the storage is still valid. valid. This can be used for easier item energy storage implementation or overridden for custom delegation. An energy storage that can't accept energy but will allow extracting any amount of energy. Creative batteries, okay, yeah, I need to stay as energy storage if I, for example, want creative ones. The limiting one says an energy storage that will apply additional per insert and per extract limits to another storage. Wow. And this is the simple energy storage. This one has get amount, get capacity, and then, yeah, max insert and max extract. The other ones are protected, seriously, and this one doesn't have any. This one doesn't have any. And finally, the item implementation. Instances of this class do not perform any context validation. That is handled by the delegating energy storage. They are wrapped behind. And empty energy storage is just an empty one, I think. Yeah, so problem is that if I don't support energy storage, then block entities can't become creative energy batteries, for example. Although infinite one has max amount for the values and capacity, it will not insert anything and it will extract max amount. If I want to go into this road and I still want to have these, I need to cover each one of these. For example, infinite storage, limiting one that has protected for max insert and max output, and it's not available to us. Okay, you know what? Bye-bye to these. That would be enough. Let's continue. If we are simple energy storage, we just do that. Else, we need to handle the transaction. I don't like this. If I'm gonna do this for the energy, I should do this for the fluids too, because I want to be consistent between libraries. Let's do that. So we say here we will try a transaction to be outer. By the way, if you are not familiar with outer, we have this top level transaction that would be outer. If we want any other transaction happening in here, it will be transaction nested or inner. That is why we always use the outer, because this is the outmost transaction that we use. Simple enough. So long current equals to storage.getAmount. Then we say if current is less than the amount that we read, then we say storage.insert the amount minus current. So this is the gap that we need to cover using transaction. Else we need a storage.extract the current, the reverse one, minus the amount with, you're not going to be smart, transaction. And at the end here we will say transaction.commit. Honestly, this is a much more robust thing compared to cleaning a fluid storage then inserting the amount. Why didn't I think about this? Anyways, I will mimic this inside fluid storage maybe in another video, but I will record it because things will be interesting. That will be our energy connector. The only thing remaining is just adding my own block entities. So this will be JiEnergy container BE. Did I call that one fluid BE or fluid block entity? Gfluid BE. What? Why? Actually, no. The block was the one. Okay, abstractly. Yeah. Okay. So Gfluid BE, JiEnergy BE. Let's change that name to be consistent. Okay. Now inside JiEnergy BE, do I want to have inventory here? Do I want to have it? I'm not depending on the inventory here for a good reason. Normally, energy containers are batteries or cables, and none of them will carry around any inventory. The only time that you have inventory is when you are dealing with machines and charging stations. Now, I will consider charging a station a machine. I don't want to. Now, in this scenario, we are closer to JInventory, aren't we? Let's take a look at the JInventory and see how did we start things. Okay, here we go with the extends GScreen BE with a block pause payload. It extends simple inventory because we want to drop the content. Well, we don't want to drop the content here, so we can ignore B here, but then we need this. So B here will be extending simple energy. Yes, so we want this whole thing. Let's copy that, but B here will be simple energy storage, not the inventory one. Then let's go with implementing methods. I just want the opening data. Now the opening data, I'm lazy, so copy, paste, and then I will have to, let's add those two methods because it's yelling at me and I want the constructor. Thank you. Now block entity T. It shouldn't be JInventory. It should be JiEnergy. That will fix that. Okay, now for the fluids, we have another interface. So I will jump back to JFluid, and inside the constructor, inside here, I will have this guy. Thankfully, here we use B again because that's the JiEnergy connector of the type. JiEnergy connector of the simple energy storage. That should work. And now we need to implement method get fluid connector. I need to change that name. So careful about copy pasting, guys. Interface, this should be get energy connector. And why are you not updating yourself? Import class. Thank you. Simple energy storage T. Oh, it became energy storage, Okay, what's wrong with you? Energy connector, extend a storage connector of energy storage. So T extends energy storage. This is energy connector of T. T is, I'm totally lost between the classes. Okay, T is a storage connector of this. No, I don't want to do that. Bound value is energy connector, energy storage from Tech Reborn. I don't see any difference, do you? Okay, what did you change here is the energy storage. Oh, yeah, we should do that, I think. Let me just double check my fluid connector. T extends. Yeah, we should do that. Sorry, you were right. Okay, change the signature, refactor, and now it's T extending energy storage. That is correct now. Okay, so we have that. Now here we should be able to implement that method, and it will return energy connector of that, and we should be able to give back the energy connector. Okay, now let's start. We will have, is it protected final? Yes. Okay, so protected final energy connector of type B, and we call it energy connector. Here we are returning that energy connector. So this dot energy connector, that works. Okay, inside the constructor, let me take a look at this guy on the second monitor so I will have an easier life. All we need to do is saying that energy connector equals to new energy connector. Then we have the connector. We don't need these two, but then we want the read and write NBT. So let's start with read NBT and write NBT. After the super, you'll say if NBT contains energy, yeah, that is stupid name, plus B keys dot has energy, NBT dot get list. Here we want the energy plus BE keys dot has energy. If present the NBT element, all we want to do is say that energy storage, or did we call it energy connector? I will call it energy storage. Energy storage, although it should be energy connector, What the? No, just these guys, for God's sake. Basically, they are connectors, and in my JInventory, I think I called them connectors. Or no, I did call them inventory. Yeah, it should be inventory connector. It should be fluid connector. Whatever, man, whatever. And this should be energy storage. So here we say energy storage dot read NBT with the NBT element and registries. For writing the NBT, we just say NBT.put the crazy name of energy plus BE keys. Why am I having two pluses? BE keys dot has energy that will eventually become energy dot BE has energy. Anyway, we put it there. Then we say energy storage dot write NBT with registries. That's that. Then we want the two providers. So it will be public. That returns the energy storage. Actually, I think it's correct. Energy storage and get energy storage of direction from Minecraft direction. We will say, basically it's a copy paste with just changing one thing. And that is, instead of fluid storage being energy storage, get the storage provider. Oh, I did forget to add these, didn't I? Okay, then I will have the overload that accepts a mapped direction. So mapped direction, all it will do, it says get energy storage of mapped direction dot to direction. Now this get storage provider provider, I need to add it. So create method, get a storage provider for direction, and this one becomes facing. Boom. Here, let me take a look at my fluid provider because that will be almost identical, or fluid connector, I should say. So for fluid connector, for energy connector, I missed something, and very important one, and that is these two implementations. So, and this is not fluid, but energy connector. And let's just implement the methods, the get connector and that. So for get connector, we return this. For the direction and facing, mapped direction and direction that is facing actually. For these two, again, I will do the copy pasting, and let's get this guy above them, and let's get these whole thing above my helpers. I will do copy paste. This one is for the map direction one, paste. So it's get a storage. Why are you yelling at me now? It will be energy storage, but we need T. T is extending energy storage, provided energy storage. Cast it to T, and yes, I know it's unchecked, so just suppress for statement or for method, why not? Now, is it correct? Get a storage should return the T, isn't it? T here is the storage connector of that, and here we are saying that we are a storage connector of anything that extends energy storage, but we want, yeah, it should work. Okay, so on this guy, we will have the same thing, and again, cast to T, and again, this will be unchecked cast. Hopefully, we will not have any problems here. I think we shouldn't, because we are extending from energy storage, and here we are returning energy storage. So the thing is that here we are getting that problem. And this is why make method void. Why should I make method void? We are just returning things here. If I make it void, return? No, I shouldn't. Anyways, I'm a little bit baffled here. It says return value is never used. Oh yeah, okay, never used. Just suppress it for the whole class. Thank you. Suppress for class. Thank you, thank you. Okay, and here we will return that. Now, I think the problem is here. That one, the energy connector, needs this cast, maybe because we are deliberately returning the energy storage here. If we say energy storage, does it accept anything? B maybe? No. Actually, you know what? Here we return B, I think. And it should work now because now we shouldn't need that stupid typecast. So let's go back, remove this typecast. Now it's not working again. Let me see. It says required B. Now B is extending simple energy storage. It should extend energy storage, provided energy storage, but we want B. And this guy is saying that provided energy storage, but we want T. So, okay, we need to do this typecast here. We need to do this typecast here. And yes, they are unchecked, I know. Come on, there we go. Here, however, it says cast to B. Now it shouldn't be now. B extends energy storage. We should be able to typecast here again, and this is unchecked, I know. Again, the same deal, inspection for the method. Now the thing is that there is a little bit of difference between energy storage and fluid or inventory storages. The energy storage is not as generic as the other two. And because of that, we have a little bit of problem here, and we need to do the typecasts ourselves because, for example, let's follow this whole logic here. Actually, you know what? Following my own words, here for the storage, we are extending from simple energy storage. And simple energy storage is, here we go, is implementing an interface. In the case of fluids and other things like inventory, they are extending a class, and that class is extending the snapshot participant. So here's a little bit of problem here. Basically, what I'm saying now is the connector can accept anything that extends this energy storage. So when I have that interface, for the, where are you coming from? JiEnergy connector is actually asking for anything that extends energy storage. But here the system is not sure. For example, let's say that we are sending a synced energy storage, okay? The inventory will say that we have an energy connector of synced energy storage, okay? Now this shouldn't be. The connector is okay because here we will say deliberately that we want a connector of a type. This one, if we say that we are synced, for example, then we can't use anything else. Not the predicate, not the output. Actually, we should be able to do that. Let me see. Let me add a test block entity. So this is test. This will extend the JiEnergy BE of, now what we need is the T being JiEnergy BE and then energy storage. Okay, so T extends, here will be test itself. What am I thinking? And then let's say that we want a synced energy storage. Okay, then we want to create the constructor and that's it. However, here if I say this dot energy storage dot add storage, you see that it accepts any sort of energy storage. Okay, so if I say new output energy storage of this dot, I don't know, 10,000 as the capacity and max insert of 100, max extract of 100, you see that I don't have any errors. So it will work. However, the thing is that because we are implementing an interface and not extending from a class in the energy system between the iEnergy connector, the energy connector, and JiEnergy, the system is confused. It doesn't know which one of them we want. Because of that, we need to constantly typecast. So for example, if I want to say var something equals to get energy storage of direction.down, for example, you see that something will become the synced energy storage, okay? Because we said that our system will use synced energy storage. And this is a problem, isn't it? Because it will talk to the whole system and this get energy storage will eventually work for just registering the sided things. However, if I want to get the connector, so get connector, it will return energy connector of V, and this time we are energy connector of synced energy storage because we said that we need synced energy storage. Now, if I convert to the energy storage, this thing will become energy connector of energy storage. So now I have to deliberately typecast anything that I'm retrieving. For example, if I say get a storage of index 0, in this case it will be the output energy storage, you see that it is saying that it is energy storage. So it will not understand the concept of energy storage being the output energy storage because we are not deliberately type binding things to each other. So if I want to now, I need to cast this to be an output energy storage, and then I can do, for example, support extraction, support insertion, and they will correctly work because I assigned it to the output energy storage. However, because of this, we will have to be careful when we are using this system because we are not, what's the name for it? I forgot. There is a name in object-oriented programming for this. When we are not binding to a special type and just using interfaces, it has a name in object-oriented programming that I already forgot. Anyway, the long story short, it will work. However, we need to be careful. Even if I use synced energy storage and I want to retrieve something, so we say var something equals to get the connector dot get storage at 0, you will see that it will return the energy storage. It will not bind us to anything else, okay? Because we are not type aware here and we need to be sure exactly what we are retrieving when we are retrieving it. Although in the case of energy system, honestly, it's not important because most of the time, 99% of the time, you will go with synced energy storage and that's it because you want something that can accept and extract energy. But in case of machines, for example, well, they cannot output energy. They can just input energy. And that's okay because we don't need to handle transferring of energy ourselves. The system on the sided thing will handle that for our machines and talk between machines and cables. The cable will eventually know that it is not supporting extraction. That's the whole point. So we don't need to be worried about these types and type aware content. All we care about right now is these typecasts are not a problem here. The problem is that the system is not type aware, okay? It's it's just using an interface. And if I want to, I can go with simple energy storage here, okay? And then this guy will return simple energy storage. So if I go with get energy storage, it will eventually return simple energy storage. And again, it will not go up on the hierarchy. Anyway, using, and this will make us able to, no, we still need that unless we go here and change this guy to be simple energy storage. I think then, yeah, that's the whole point. Then again, we need to bind this guy to be simple energy storage, and I don't want to do that. So Control Z and Control Z and Control Z. So that's the whole thing. Now, believe it or not, we are almost finished. The only thing remaining is a helper method. And no, it's not as hard as what we had for the fluids. Let me show you the whole thing. It's just more than enough comments, and the whole thing will not be any hard, but this video is taking long. So I will stop the video and I will come back in the next video. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.